Okay, CNT140, we are working on our cable certification lab. Now, before we dig in, let's talk a little bit about the meter, why we're going to do this, and then we'll get into the how we're going to do it. All right, first thing, the only type of meter that's actually able to do a cable certification is a cable certification meter. And you notice in this guy, it actually says cable certifier, and if I look at the connections up top, that's a copper connection, so this is a copper cable certification meter. That's the only type of meter that can actually do this because it's actually designed to run a battery of tests, not just wire map, but things like length, things like crosstalk, things like attenuation or insertion loss, those kind of things that none of our other meters can run. So this will actually run that battery of tests on the cable run to make sure all of those parameters are within value that the cable run will be able to do, 100 meg or gigabit or 10 gig data connection across it. If all those parameters are in range, if you will, then that cable run should be able to support that. That is the only type of meter that'll do it. And you'll notice that this meter actually is in two pieces. Here's the main meter part, and here's the remote part. So the way this actually works is just like your little continuity test that we use. It's in two pieces. This will do the same thing. The meter will connect into like the outlet per se, like here. And then the remote would be used in the closet to connect into your patch panel. Okay, so this is going to be used in very similar format as your continuity meter, just in two pieces. All right, why in the world are we going to do this? Well, first off, after we install all of our cabling, we got to make sure it's working correctly. So this meter will check that it's working correctly, but more importantly, it's going to check whether it's going to perform at the necessary level, 100 meg, gigabit, 10 gig. We need to make sure it's going to perform at that level for its intended purpose. So when we're done installing cabling, we need to check it for functionality, which your continuity checker could do, but then we need to check it for performance. Will this perform at 100 meg, gigabit, 10 gig level? This is actually going to be able to do that. And when we're done, if we test with this, we should be able to have some confidence in that all of our termination techniques on the outlets, the patch panel, everything we're in, good enough quality that it'll support that gigabit or 10 gig connection we need. So this is ensuring that all of our work is up to the correct level to support gig or 10 gig. In addition, we want to be able to tell our customer that it's going to perform to that level. So we would be able to, after we test all of our cable runs, verify to the customer, yes, it's all working, and we're actually certifying our work that it's going to work as it's intended to. So this is really for making sure all of our work is good, but also that our customer knows that all the work is good, and we may even be able to provide them a warranty that, yes, everything we installed is going to work as we said it's going to. So there would be the reasons. All right, how are we going to do it? Well, let's go through the process. I do have my patch panel from the previous lab. I have a couple cable runs on here, terminate into an outlet box, a couple of these outlets. So I'm going to certify at least one of those cable runs to make sure it's working correctly. So first thing I do with my meter, again, we only have one of these for our whole lab room, so it's not something I could even sign out to you. If you look up the price of these are in the $5,000 to $10,000 category for pricing. These are not cheap. But I'm going to first set up my meter. I will actually go into in here in my preferences, and there's a couple different things I need to set on here, things like language and feet and distances and time and date and those kind of things, the color code I'm going to use, that sort of deal. All right. So once I've done that, I then come down to my test standards and indicate whether I'm going to use TIA, ISO, etc. Well, we're going to use TIA, and we're going to indicate that we're using a twisted pair permanent link test. Now, when we certify, there's permanent link and channel testing. You'll notice down here there's a third option for channel test. We're going to do permanent link because permanent link tests between the outlet and the patch panel. It does not include any user patch cords. So we're going to do a permanent link test. So we would check that or indicate that and then tell it what category. In this case, this is category 5E. That's what we have. So we would say 5E UTP permanent. And now as I look on the front screen out here, I see category 5E UTP permanent. So we know that that has been set, and that is the test parameters we're going to be following. Once I do that, I'll go back to my home screen, and I'm actually going to do a field calibration on this guy. I'm going to try to show you this. This is a little tricky in my limited space here, but let me slide my patch panel outlets out of the way. And I have two tester cords. Let me see if I can lay these here for you to see. These are two tester cords. Here's one, and here's the second. These are designed to be used with the meter. We're not using plain old ordinary patch cables. These are tester cords designed to use with the meter. So we're going to say field calibrate, hit enter, and it's going to give us directions on how we hook them up. So I want to take my, this I'll call my right-hand cable, this I'll call my left-hand cable. It wants me to hook the right-hand cable between our 2 meters. Between the meter and the remote, I should say, not the 2 meters. Between the meter and remote. So I'm looking for, there we are, there's the connection there. I'll look for the connection here. And I'll click the start button. I know our cables are kind of getting in the way. And it's actually going to test this cable and try to learn what it can about it. And kind of like keep that in memory. Once it's done that, it's going to indicate that's done, and it wants us to hook up the other cable. So I'm now going to take the other cable that I had over here on my left hand. I just had it hidden off the screen, if you will. I'm going to hook that over here and into my meter. And I'll hit test again, or continue, if you will. Let that run and learn about that cable. Now it wants me to do left-hand cable over here, leave it in place. Take the right-hand cable that I had used previously, plug it into this side, and leave it in place. And it's going to want me to hit start over here to finish the calibration on this one. Hit auto test over here to finish calibration on this cable. Once it's done that, I'll see a pass over here that it's okay with this cable, and I'll see a little pass check mark over here that's okay with this cable. What I need to do at this point, I'm just going to exit back out to the main screen. It's calibrated, and I need to leave these cables in place. I don't move them around, I don't change them. I leave them in place. I'm now going to use these cables to test my cable run. So, I'm going to try to get my cables out of the way here. I would take one end of my meter, either the meter end or remote, out to the outlet jack. So let's take this cable with this main meter here, and I'm going to plug it into my outlet jack number 2. The other end of my meter, my remote end, I would walk to the closet. I'm going to take that cable and plug into patch panel port 2. So I'm going to plug that meter, or the remote if you will, into the patch panel port 2 in the closet. Okay? So it's here. In real life it would be in the closet. You would not be able to see it. Alright. What I need to do now is, since I set all the parameters of, hey, please use permanent link, TIA 568 permanent link 5E test, it knows what tests to run. So if I hit auto test, it's going to go through that series of tests. And you're hearing it click away because it's literally running tests on each wire pair and each wire and each wire pair. It's doing things like length, it's doing things like attenuation or assertion loss, it's doing things like crosstalk, wire map, all kinds of tests to say, is this cable run a usable cable run? All right, now that it's done that, I'll see a green successful check mark, and it's showing that it's passed. So what I'm going to do is rename this cable run, and I need to use kind of like old school cell phone. Oops. I need to use like old school cell phone, brick phone kind of There we go. We'll say CNT, and I'll do 0, 2. And that'll tell me that that is CNT port 2 for this. In real life, I might want to give it a little bit more detail of like the room or building and port number and that sort of thing. But for what we're doing, I just have ports 2, 4, 6, and 8 terminated. So there's my port 2 result. If I were to continue, and actually this meter's set up that I could continue to start going down the line and testing all the cables in my closet, if you will, I could, there's actually a spot on here that I could plug a headphone in so that me and my partner, because my partner would be in the closet with this one, we could talk over the headset and say, okay, now plug into port 4, now plug into port 6, now plug into port 8. And we could just start testing run after run after run and continue saving these until we're done with our job. So let me move. I'm going to move the cable to port 4 in the closet. And I'm going to find port 4 here. There was port 2. Let me find port 4. Here's port 4. There's port 4. Oops. There we go. Now, port 4 is actually wired up with a fault. There's actually a fault in port 4. So I'm going to go back to the home page here. I'm going to hit auto test again. And it's going to encounter a problem this time because 4 is purposely wired with a fault. You'll see a big old red X. And if you heard it, it actually went, and even this end comes up with a little fail light. So again, me and my partner would be able to see that this failed. I would save the results, take note of this run, and later on come back and say, hey, we got to troubleshoot this run. Well, if I do actually look at the results here, I'm going to hit the enter key. You'll notice it failed the wire map, so I'm going to hit the enter key again, and it shows that wire 4, if you can see it there, wire 4 is missing. So there is a problem, and I can do a fault here, and it's saying, hey, at about 9 feet, it's open. So about 9 feet from this end, we have an open. So I could start troubleshooting to figure out about how far away is that. Well, 9 feet is actually going to be over at the patch panel. There actually is a fault on the patch panel. But this is going to give me a clue as to where that fault is. And since it failed that, I might save this result and keep moving. And me and my partner can make a list of things I would need to go back and troubleshoot and fix for our customer, so all of our cable runs are working before we turn this whole job over to the customer. So there would be a fault or a problem showing up on our meter. So there's how we actually set up the meter, do the tests, run the tests. What I would do next in real life is I would take this meter back to my office, if you will, and there is a port on the side that I can download all the results on the USB drive, put them on my computer, and I would have those results that I can save as PDFs and give to the customer, or I could print them out. And here is actually a printout of a test result that we did. This was actually last spring. This was actually last spring, right before we got into the whole... actually, this was the previous spring. This was spring of 19. There we go. That's when that one was. And here's November 18. But here's spring 19. Here's a printout of our test result. Lots of numbers, lots of results. But just give you an idea, here's the summary up top. It passed. Here's the summary of results. And then these are specific details of that test result. Wire map, insertion loss. Over here is here's our near and crosstalk right here. So this gives me an overview of all the parameters of this cable run to know whether it passed or not. And if it didn't, I would see little details letting me know what the problem is. So there is actually certifying a cable run for a customer. And again, it can only be done with a certification meter. And we're doing this to locate problems, verify everything is working correctly so that we could turn it over to the customer saying it will carry gigabit or 10 gig. And with that, we'd be able to warranty our work, saying, yes, everything worked. Here it is. Here's your cable plant. Have at it. So there's the testing with our certification meter.